STL, Standard Template Library. This has algorithms, containers, and iterators. Let us understand what these are. See, there are built-in algorithms or functions that are meant for managing these containers, performing operations on the containers. Now, what are containers? That's it. Array, linked list, stack, queues, what all we have seen already, those are containers. For them, there are built-in classes. Those classes are called as container. Container contains collection of data. That's it. List of data. So those are containers. We will see about these. Then there are iterators for iterating through the collection of values. So for accessing these containers, iterators are available. First, let us briefly look at algorithms. So there are algorithms for searching in a collection, means searching in an array or linked list or in a queue or DQ, whatever it is, searching in the data structure or sorting data structure, performing binary search or reversing data structure, means collection of elements. All these functions are available. So you can explore these functions and use them. Some of the functions I'll be showing. And there are functions for concatenating two collections. And there are functions for copying one collection into another. And there is an algorithm for performing union operation and performing intersection operation on the collection. Performing merge or creating heap. So like this, functions are available. So there are many types of functions like this. The exact names may be a little differ, but whatever the purpose of the functions, I have written all of them here. So algorithms I have finished. Now let us look at containers. So I will list down the containers, and the important thing is we have to discuss about containers only. Let me write down the containers that are available. See, these are all container classes, and all these classes are template classes. Means they are generic. They can work for any type of data. Now let us see how they are implemented. This is a vector. This is nothing but an array only. So already array I have explained you. So this is not fixed size array. This can grow and reduce by itself. How an array can grow and reduce by itself? Already I have shown you that we have to create a bigger array and transfer those. So that's what it automatically manages that part. If you are going on inserting more and more elements, then it will create a bigger array and transfer. If you go on deleting the elements, then we'll create a smaller array and copy the elements. So this will dynamically manage the size of an array. So this is self-managed array and it is called as vector. So this class is just an array and it is called as vector. So let us see what are the functions available in this one. There are functions like push back, so you can insert the element at the back of a array, or pop back, from the last end of an array you can delete an element. Push back for inserting and pop back for deleting an element. Then if you want, you have a function available here for insert, and there is a function available for removing an element. So insert or remove an element, right? And you can know what is the size, and you can know whether it is empty or not. This type of functions are available on this. So this is a vector. That's it. So I have explained you about the vector, how to use and all. I will explain afterward. Next, let us talk about list. This class is for doubly linked list. So already I have shown you that a doubly linked list will have some data and pointer to next node as well as previous node, right? So this is for doubly linked list. So you don't have to write down the code for creating a linked list in C++. Directly use this class. And it's a template class. You want a linked list of integers or floats or your own objects, you can create an object of any type. Then what are the functions it is having? It is also having same functions, but is also having other functions like push front, pop front. So it means you can insert and delete from either end. And you can say just front and you can get the first element, and back you can get just the last element. So insertion and deletion is possible from both the ends. And insert, you can mention an index and you can insert at that place. So these are the functions in list. That's all. Next, forward list. This is a singly linked list. This is introduced in C++11. So this is for singly linked list. So that's why the name is forward list. If you know that you are going to access only in forward direction, then avoid doubly linked list, because doubly linked list needs extra space for previous, next, both the pointers. So whereas forward linked list just needs a pointer to the next node. So you can take a forward linked list if you have to access only in forward direction. And what are the methods? Same set of methods are available in this. So these two are linked list. Now next, DQ. DQ is same as vector, means it's an array only. But DQ means double-ended queue. From both the ends you can insert and delete. So what are the functions it is having? It is also having the same set of functions. So list, forward list and DQ, all of them are having same set of functions. Only in vector you cannot insert from front or delete from front. But in DQ you can insert from any end. I will show it like this. Suppose you have an array. Now if you want to insert a value, now if you want to insert 50 from that side, so insert it. If you want to insert 25 from this side, so all these elements has to be shifted and 25 can be inserted. So for insertion from this side, the elements have to be shifted. So that was not allowed in vector, but it is allowed in DQ. It's a costly process. Now same way, if you delete 25 from here, all the elements have to be shifted this side. So this is allowed in DQ. But insertion from this side and deletion from this side is easy in linked list, doubly linked list and singly linked list. So if you are aware of data structure, it's easy. That's why push front and pop front are available in this one also, and this one also, and this one also. So you should know what you need. Based on that, you can select any one of these data structures. Next, let us talk about this. I'll remove few things here. Let us see next. But before that, see, we have finished array is in the form of vector, list, doubly linked list, singly linked list, array only, but either direction access, double-ended queue. Now what is priority queue? Priority queue is for heap data structure, and it is for max heap data structure. It is having the functions like push and pop for inserting and deleting the elements. Actually, these operations are for stack. Yes, the same operations are available on priority queue also. So I'll explain you what is priority queue, but first let me finish some function. And is having functions like empty and size. So you can insert an element, delete an element, check whether it is empty or not, and you can find out its size. What is this priority queue? So listen, whether you know about max heap or not, listen about the priority queue. So priority queue means always the largest element from the queue will be deleted. From the data structure, whenever you delete, the largest value will be deleted. And when you insert, how they are arranged and all, we don't bother. That is not in the form of a list. It is not ordered form. That is not in the order. In whichever order you insert, it will not be in the same order. So this will be deleting always maximum element. So that is priority queue. So that's max heap. So if you study about heap, you can understand. Then stack, this works on discipline last in first out, and it is having same set of operations. So I don't have to explain. That is last in first out. From the top only the elements are inserted, from the top the elements are deleted. That is push and pop operations. Now set. This is a collection of element which will contain only unique elements. Duplicates are not allowed. This will not be maintaining the order. It will not maintain the order in which you have inserted the elements. The next, multi-set. This is same as a set only, but allows duplicate. That's all. There is one more data structure called as map, and this is useful for storing key and value pair. You can store key value pair. For example, roll number 1 is John and roll number 2 is Ajay. Roll number 3 is Khan. So like this is the key and this is the value. So we store key and the value. Whenever you want to find, we will give the key and we get the value. So this is a different data structure. This actually uses hash table and it will contain unique keys. Then there is one more, that is multi-map. Now this is same as map, but keys can be duplicated, but same key value pair should not be there. Duplicate keys are allowed, but the value should be different. So that's it, that is multi-map. So this is for hash table. So if you have the idea about hash table, so you can understand. So I have explained you about all the containers. Now the next is iterators. So for showing iterators, I will write one program and show you how to use these data structures, right? And through that only I'll explain you about iterators. Then rest practically I will write on the code and show you. So next I will show you one program how to use these data structure as well as iterators.